subtle review things that you have seen. You just probably forgot. You haven't done them in a while. It'll come up more and more. It'll come up more later on. We talk about domain and range pretty regularly. Well, let's see here. First thing I should probably define with you guys to see if you remember. Do you guys remember what defined a function in terms of math? What was it? Yeah, it's flipping. Yeah, so what happens for every value of the input, there exists exactly one value in the output. So every value you put in, you get one value out. So your input is your x, your output is your y. So in order for something to be a function, they do a very long-winded definition. And don't write this out. I hate long-winded definitions. I think they're stupid. For every value that exists within the domain, there is an equal value in the range. Along those lines. Basically, for every x, there exists only one y. And there's a really easy way to tell if this happens. You can see it visually. You can see it in a table form. It's super simple. For example, if you have a graph, we talked about that before, right? Parabola, up like a cup, nothing crazy. Okay. For every value that's in the x, there's exactly one value in the y. Your x values are your x values are your domain. Your y values are the range. Another easy way to remember that, what comes first in the alphabet? Domain or range? Domain, what comes first in the alphabet? X or y? X, and then Y and Z. So that's the idea. It's a dumb way to remember it, but it comes in helpful a little bit later on as we go. Right? So for every value that's for one value of the domain, there will exist one value in the range. You remember this thing? We called it the vertical line test. Remember that graphically? You take your pencil over a graph. Does your pencil only touch it at one spot all the way around? Yeah. If it passes the vertical line test, that means that there's one value of x that has one value of y. Whereas if this was turned this way, that's still a parabola. It's no longer an x squared parabola. It's now a y squared parabola. Is this a function? No. It's no longer a function. Is a circle a function? No. Okay. So we'll have things that are and or are not functions, and it's very simple to see. Because here, if you have your x value at, let's say, 3, well, I'm in two different spots, so it doesn't work. Okay. It's things like that. That's what we'll get to eventually. Right away, but just the idea. Again, this is stuff that you've seen. This isn't anything crazy. We talk a lot about domain and range as we go on. We'll talk about what's called horizontal and vertical shifting. Horizontal, you move left and right, your x values. Vertical, you move up and down, your y values. Again, what comes first in the alphabet? Horizontal or vertical? Horizontal. Okay, so H goes with your x because they come first in the alphabet. These dumb little sayings that I'll use to help get you guys to remember certain things. Super exciting. We get this already. Remember this? Did you just roll your eyes already? I mean, it's not even 8:20 and you're rolling your eyes. Slopes, you guys remember that? How do you define slope? That's slope-intercept form. That's graphing. Rise over run. Very good. So slope. Oh, what letter do they use for slope? Remember? M. Do you know why they use M for slope? Well, look at the letters. How can we spell the word slope? S-L-O-P-E. What does an S look like? 5? Yeah. A lot of times people, well, you'll realize real quick my handwriting is, I try. It's early in the year, so I'm decent-ish. 12th hour, they're screwed. I'm just toast by then, right? But a lot of times they like to think people, they don't use the S because S usually it looks like a 5. What does an L look like? A 1. What's the G? What does an O look like? What do they use P for in math? Probability. What do they use E for? Exponential. Exponential. Very good. Now go through the alphabet. What are A, B, and C used for? A squared, B squared equals. Those are used. What's D stand for? Distance. Very good. E we talked about. F, G, and H. Well, F, G, and H, they're all used for the same kind of general purpose. H, height a lot of times, but F, G, they use that a lot of times for function, what's called function notation. Okay? You'll see that later. We'll do stuff called F-O-G, G-O-F, stuff like that. Do you know what I stands for? Imaginary numbers. So you can think about them, but you can't talk about them. J, you know what they use J for? All right, so J later, you guys like, you guys, do you vaguely remember a thing called direct variation? Direct variation is, we'll say like X and Y vary directly with a certain constant. It's basically a precursor to learning what slope is. Joint variation is the same basic principle, but it adds on a secondary variable. So J is always used for what's called joint variation. K, they use that with that one as well. L we did, and then we got to M. They went down the alphabet and they figured out, well, they haven't used M yet. So. Math people look for the easiest way to get something done. Look, you learned something absolutely useless today. Very useless. So anyway, like you were saying, slope was your rise over run. On a graph, what values are the rise? The x's or the y's? The y's. The y's go up and down, the x's go left and right. So we say it as the change in y over the change in x. You guys ever seen it with triangles before? It stands for delta. Delta is the Greek letter that represents change. So change in y over change in x. And a lot of times what we do, we have ordered pairs. You've got your first set of ordered pairs. You've got your second set of ordered pairs. And the way we would do that is we would write it as the second one minus the first one, second one minus the first for that. And that's what you would do. You've all done this. A lot of times you can do this really quick in your head. Biggest mistake people generally make when we're talking about slopes and writing out and finding slopes and stuff is you'll screw up a subtraction sign with a negative. What's nice with your calculators, you could literally put in the values with the negatives and subtraction symbols, hit enter, and it will always give you a fraction in an improper fraction, top heavy. Mixed numbers no longer exist. I want you guys to forget that 2 1/3 is a thing, because it's not a thing. 2 1/3 is now called 7/3. Okay? So you have all forgotten a thing about mixed numbers. There will be probably 2 times this entire year that a mixed number makes sense to use. We will steer clear of them pretty much nonstop. There's just no use for them. which is nice because these calculators will just put it in improper anyway. Okay? Did you have a question? Good, I didn't want to help. I'm a really nice person. Really? What? You don't believe me? Why are you laughing? No. Come on. Do we have to do an example of how to find slope? No, we don't. I don't need to. All right, let me think this. There are 4 types of slopes. What are they? You have positive slope, okay? Therefore, you have negative slope. You have horizontal, very good. So, do you guys remember what direction positive slopes look like? Which, yeah, they go that way. Positive slopes, up and right. Yeah, positive. Up and right's the same direction as down and left. Okay. Up and right's the same thing as down and left. Because if you go down and you go left on a graph, isn't that negative, negative? What's a negative divided by negative? Very good. Okay. So you have positive slopes, you have negative slopes. And then you were just saying you had horizontal and vertical. Now, when you have horizontal and vertical lines, what direction is a horizontal line? Side to side, it goes left to right. We okay with that? Like the horizon. Is it too early? Yeah, you'll get over it. And then vertical would be side to side if you're lying on your side, yes. So if you're lying on your side, then it's side to side, so yeah, you're not wrong. It's all about perspective, right? So you can word things differently. It's like going back to this. Where was it? It's like when I went back to here. That was all BS. I made all that up. And you guys are like, oh, okay. Remember 80-20? That was a 20. Slope comes from the word modulus. Anyway, so see? You gotta be careful how to trust me. Got you on the second day. Oh, but whatever. And then vertical, just it can't count. Come on now. Which one of those has a 0 slope? Which one of them has an undefined slope? Horizontal has a 0 slope. Why do you remember it that way? Because there's an O in it. I got you. But I always remember because there's an O in the word horizon. So the slope is 0. And then I just talk about horizontal, don't miss my words. And then obviously your vertical is your undefined. Your undefined slope, because that means your x value on a vertical line never changes. If your x value never changes, that means the difference between them is always 0, and you can't divide by 0. That's what that's for. So those are your 4 slopes. I know. about to ask you if you know what those symbols stand for. Parallel and perpendicular, good. Now, parallel slopes are what? If two lines are parallel, what do they have? What are their slopes? They're the same. Parallel lines they have same slopes. Okay. Versus perpendicular. When you are perpendicular, you create a right angle. Okay. Now, if you're going to be perpendicular, what was the relationship between the slopes? Do you remember that? Opposite reciprocals. Very good. Perpendicular slopes are opposite reciprocals. For example, if your original slope is 1/2, I'll abbreviate original, which is ORG. I'm sure you guys are going to be able to figure that out. If your original slope is 1/2, what's your parallel? What's your perpendicular? What's parallel to 1/2? 1/2. Okay. What's perpendicular to it? 2/1, or is it negative 2/1? Negative 2. Okay. Opposite reciprocals means flip the fraction, change the sign. And a lot of times when we have a whole number, we just write it as negative 2. It's implied that it's over 1. You can write it over 1. I don't care. It doesn't matter to me. I'm just saying it. Now, the weird one will come in when you have something like this. If your original slope is 0. If your original slope is 0, oh crap. With any luck, 7/3 is the slope stuff, right? No, it's not. Oh, that's 7. I'm in the wrong chapter. You should be able to do. Hey, just do the 2.2 stuff for tonight, okay? We'll worry about the graphs and everything tomorrow. We'll start with that tomorrow. I didn't know how far we're going to get with the other stuff. Yeah, just do the 2.2 stuff, guys. I'll back out the rest of it later on, so you don't have to worry about it. I'll switch that stuff to tomorrow. I was rather ambitious today, but I got in that long story about slopes and couldn't contain myself. It happens.